So I just got done doing the UART video, and I figured, you know what? Let's move on to doing that LED thing. I kind of like that idea as a project, so I want to go over real quick again how to control the GPIO on this thing, and specifically, let's say blinking an LED. So focusing on output. To do this, again, I'm not gonna lie. I always like to go to the Resource Explorer. It's been a hot minute since I've had to program this stuff, so I'm just gonna use the examples they have for me. So if I go into Resource Explorer, if you haven't already picked your board, go ahead and do that. And actually, what's kind of cool is it tries to remember what board you connected, and if so, it remembers where you were looking last. So let me go to the peripheral examples, the register level, and I'm going to look at not just blinking an LED, I want to control the brightness of the LED. So instead of just doing turning an LED on and off with just like P1 out, instead, I want to see if I can do some pulse width modulation. Just from experience, I know that this would be something that the timer module is capable of. Depending on which example you want to use and things like that, there's all sorts of cool stuff that you can use. So I believe these, unfortunately, you're going to have to kind of look around. But, for example, toggle P1 using timer A0 in up mode. So maybe I'll use timer A0. Sure. Let's pick this one and see if this is a PWM. It is not. But I will... Should I go with it? Too simple. Let me pick another timer example here. Let me do like timer 16. Did I do it? Yeah, that one's PWM using submain clock. So I'm going to go ahead and import that. Why did I pick this one? Well, because, I don't know, the other ones, I wanted to do some PWM. So you just saw me go through my work here. So it'll import it into the workspace. And if you notice, we have the UART code here. I didn't get rid of it because we're going to merge these two things together. So this code, for example, uses the timer module. Let me close the Resource Explorer. So this code, what it's doing is instead of manually taking control of P1 out, if you take a look at your, again, the data sheet, I can't stress this enough. You know what? I'm going to pull the Resource Explorer up again. I cannot stress enough how critical it is for you to just have these up and running constantly available for you. So here's the G2553. You need to have the data sheet and the user guide just on hand. So if I'm going to control this LED, that's pin 1.1 or 1.0. On the G2 board, it looks like 1.0. So here's what I want to do. I'm going to look here really quick, and of course it won't let me zoom in conveniently. But I have the 20-pin package, and if I take a look at... Let me zoom in and let me see if it'll actually... Nope, it doesn't let me pan either. If I look at pin 1.0, which the LED is connected to, it's hooked up to a couple things here. It's hooked up to GPIO port 1, pin 0. There's comparators, a clock, analog digital converter. What I care about though is this. It's hooked up to TA0. Is this on 1.0? And also, what's my code? Sorry if I'm bouncing around, but what's my code controlling? Pin 1.2. Let me check and see. Pin 1.2. Okay. So the reason I'm checking back and forth is because they're picking 1.2 here. Great. What does that mean for me? Well, originally I was going to try and do 1.0. However, it looks like 1.0 actually does not have hardware PWM control. I can let this be the clock signal from the timer, but pin 1.2 and 1.1, if we take a look, actually has timer control. So meaning the timer peripheral can actually take control of this pin, which is a lot nicer from my perspective. And actually I'm going to look at, you know what, I'm going to get port 1.6 working. So 1.6 is hooked up to my other LED. This one's the green one. So pin 1.6. So 1.6 is hooked up to timer A0 channel 1 or CCR1. So here's what I'm going to do. I'm going to take and morph this code live to what I need. So instead of doing 1.2, I want to try and get 1.6 working. And I know that that's going to be timer A0 and it's going to be capture compare register 1. How do I know that? If I go back here, timer A0, capture register 1. Capture compare register 1. So TA0.1. So I need to figure out how to convert this. Well, just by inspection, and even if you didn't know anything about the timer modules, if I change this to be, let's see, 0.1, then here's what I got to do. I'm going to go down here and look. Okay, so this is my watchdog timer stuff. All right, so this next line of code is setting my port direction for a specific pin 1.2, to be an output. Well, now I'm dealing with pin 1.6, so I'm going to change this to bit 6. For the select bits, again, so I'm setting it as an output, select. I want this to be bit 6. Now, you may be wondering, well, wait, where did you get that number from? Why are we setting this or equaling to 1? What does that do for us? Guess what tells you that? You guessed right, the datasheet. So the datasheet and the user guide will both tell you how to set up everything for your registers and things like that. So for example, if we take a look, P1 select, right? Port 1 select. If I can actually do a search function in here, that would be amazing. The answer is I cannot. So instead, I'm going to see if I can download it and view it as a separate file. That would be really cool. I think it downloaded. Hopefully it downloaded. Maybe it downloaded. Hey, it didn't download. Cool. Come on. Sorry for this. I just want to make sure and see if I can actually get it. Cancel. It's already there. Hold on. MSP 430. If I can spell correctly, MSP 430. And go to Documents. Where is my PDF? Perfect. So let me open this up real quick in an actual PDF editor so we can actually look at something. So let me show you how I use this. So just to preference the motivation here. Again, I'm going through here and I want this to do what I want. I want pin 1.6 to be controlled by the timer. I went to the datasheet and saw that it's controlled by timer A0 and capture control register 1. So I'm going through this code and I just want to see what I'm doing here. I want to take a quick inspection what these registers are actually doing for me. So I believe the syntax is PX select. Yeah, there we go. So we can actually see what the ports, the actual pins are doing here if we wanted. So for example, PX select bits are choosing a MUX and it's saying, hey, I can say it's either an input or an output. Where do I want my input to be? Well, it would be really nice if I could have it go from my timer that it's connected to so it can have control. So I need this to be set Y. I need pxselect.y, so the first bit to be a 1, and I need the second one to be a 0. Cool. You can also see that these have impacts here as well. There's all sorts of stuff. You should really take a look at these diagrams to see what exactly they're doing. If I scroll down a little bit more and go to my, let's do, of course now I can't find my basic port because I'm blind and it's a little late at night, so I am having issues finding everything. You know what, let's just do next. Let's just hit next. We're going to keep going until I find my register that I care about. As it looks like I may not. Come on. I don't want this to be a wash and you waiting for all the time. Let's do, can I do pxdir? Will that tell me what it is? So you may be wondering, like, great, it doesn't show me anything. Guess what? That probably means it's in the family user guide. This big honkin' 600-page monstrosity. So real quick, just again, I might put a timestamp in here a little bit later to skip in case you really don't want to read through this thing or watch me go through this. But ideally here, what I'm trying to do is, again, figure out what that's doing. I know what it does personally, but I just want to show you the process here. So it's like, great, I want to see what my ports are doing. So let me look at my digital I/O You could read all through this stuff, and you probably should. And look, here's every register you'd ever want to know and what they do. So look, PXDIR. So we're setting, for example, P1 direction bit 6. So we're taking pin 1.6 and setting it to an output. That's what this register controls. Now we have the function select registers. Cool. So PX select and PX select 2. We actually are forcing them here to 1 and 0, and that means primary peripheral module function is selected. That sounds specific. How am I supposed to know what that means? I don't know. Maybe go to the specific datasheet for the processor, and it will tell you for that module what is actually happening. So you have to go to your specific port. Wow, this thing is really lagging right now, so that's cool. So I can actually go to the specific pin, which is, let me just look up P1.6. Wow, this thing really hates me right now. It's so laggy. Stop. 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 Come on. There we go. Okay. You see this table here? It actually tells you how to do everything. So this is what I wanted to look at was, maybe it will behave now a little bit nicer. So if I look at what pin 1.6 does, and I want it to go from the timer, come on. I'm doing this so you don't have to, even though you should really know how to read these data sheets. Wow, this thing is running crazy slow right now. Stop. Okay. I know this is painful. There we go. It's now letting me control it. Alright, P1.6. Here's everything that's on it. So if I come here and I want it to say, hey, I want it to control by the timer because I know the timer can do PWM, I need to set the port to a 1. We do that. I need to let port 1 select become a 1. I need port 1 select 2-bit to be a 0. And then it tells you how to basically carry on with yourself. This table is incredibly important so that way you can swap between things. So that's what this is doing. Now we have CCR0. So what this is going to do for us in terms of timers is this is actually going to configure the timer to run pretty much everything we need to. So this is going to set our timer to run over a period of 512 minus 1. So it's basically going to count up to 511 and then go back down to 0. It's an up mode, so it's going to count up and then back down to 0. Go back up, down, up to 511, down to 0. So that one sort of makes sense if you've looked at the timers a little bit. This, though, is a little weird, right? CCTL, out mod 7. What's happening with that? So I'm going to come back here, see if I can find CCTL. Okay, so timer A, or timer 0 and timer 1, so CCTL, so capture compare. Well, that sort of helps, but what the hell is out mod 7? So I'm going to go out mod and see what happens. Nothing. Let's go to the family data sheet. Out mod. Hey, look, it looks like it's maybe controlling something in the block diagram. Maybe they'll give us a little bit of description. The output modes. So in the timer, you go, okay, in the timer peripheral, you could search for this, but I'm just going to look in here and, hey, look, the out mod. So it said out mod 7. So if I count that in binary, that should be 111, right? So it's saying I want to put the timer into reset set mode. So it's going to count to the value that we've set in our capture compare register, and then it's going to reset. It's going to set reset. So here's let's look at reset set. Come on, don't be so laggy. So as our timer begins to count up in up mode, so let's say we have a CCR0 and a CCR1, which, let me check our code. We have our CCR0 set and CCR1, which sets our duty cycle. So if we take a look, as the timer begins to count upwards, once we hit the CCR1 value, if we take a look at what happens, it holds to a 1. Once we hit that CCR1 value, it drops it to a 0. And then for the remainder of the time as it's counting up to CCR 0, it stays low. But as soon as the timer resets, we hit this limit and we go back down again, it resets itself back up to a 1 and then sets it to a 0. Hence the name reset set. So it's resetting to a 1, setting to a 0. So that means if we're actually doing PWM, we can control the pulse width by controlling CCR1's value. And we're going to look at how to set that actually here in a second. So we're actually going to mess with that in the debugger. So that's the basic idea here. Once again, the timer's going to count up to CCR 0 and reset. When CCR 1 gets matched and it's set to reset set mode, once we hit CCR 1, it'll drop to 0 and then come back up to a 1 once we hit our limit, or hit our CCR 0. So I'm not going to mess with that because right now I just want to see if we can actually get this thing to work. So cool, we got that. We got outmod 7, CCTL 1. Should this be 1 or 0? I don't know. Let's hover over this and see what this says. Because that's kind of one of the things about Code Composer is this sometimes can actually be extremely helpful. So if you also want to see what this does, you can right click and I believe you can say open declaration and it'll actually open the header file. So if you look at it, it's timer A capture control. Cool. Do I need to set this for anything else? I believe this counts for timer A0 and timer A1. Let's see. Let's try it out. You know what? I'm just going to try it out as this thing freaks out. Come on. There we go. All right, so now we have tactile and tassel. So these are all timer settings. Again, you can go through that whole thing of going through the data sheets. But basically what we're saying is we want the timer to be controlled by the sub main clock, which runs at 1 megahertz, and we want to run it in up mode. And then we're going to enter low power mode, which basically says turn the CPU off. And we're going to just let it run for eternity. So let's program it. Let's debug and program it. So it's going to build it. Let me save my file. Go ahead and run. Proceed. And it looks like it's finishing. There we go. Let me switch my oscilloscope pin to 1.6 to make sure I'm actually seeing the output of the LED. And I'm going to run it. And would you look at that? I have control of my LED. Now, it's a little hard to see without, your eye. You can maybe see, oh, it looks sort of dim. But if we really wanted to actually check out what's happening, we can use something like an oscilloscope or something like, I don't know, Scopy. So the thing that you all hated from Pekka is coming back to actually be extremely useful. So this is a little dirty looking, but right now this is what our PWM signal looks like. It's literally turning on. So let me get a single capture here. So it's repeating itself every so often, and it should be every, you can back calculate it from the capture compare register settings. But what you do here is you can actually see it happens every so often, and we actually have a pulse width that is greater than 50%. Cool, so let me run it. I'm going to go back here. I'm going to see if I can pause the code. It's paused. So now what I can do here is actually go in here and change my settings in my registers. I want to check and see if I can control the PWM here, the duty cycle. And just to show you, our processor's halted. I want to see if I can control the duty cycle. So 384 must be 75% of something. So here's what I'm going to do instead. I'm just going to go simple. What happens if I make it 100? So if I go back to my data sheet real quick, and hopefully it doesn't freak out, I've just moved this CCR1 value, this thing right here, I've moved it sooner. So according to the reset set mode, what I should effectively see is that this thing turns on for a little bit and then off for a longer period of time. How can I do that? Well, I could change it in the code, but I'd have to recompile it. Instead, let me go to the timer that it's actually being controlled by. So timer A0, here's all of our status registers. Well, I need to change CCR1. This is in hexadecimal. So let me actually change it to... You used to be able to change it. Come on. Number format. Let me change it to decimal. So that's 384. Cool. What if I change it to 100? It's now actually gone in. So this is what's really cool about the Register Explorer. I've actually gone in and changed the value in the register while we've paused the processor. So now if I run it again and come over here to my scope, well, we've made it more narrow. Kind of see how that sort of works? Just to make it perfectly clear, half of 512 would be 256. So by using the same trick of pausing the processor and changing this to 256 and telling it to run again, it should be about 50% symmetric. And it is. And on my side, looking at the LED, it's about 50% brighter. It's somewhere around there. So this is how you can actually just use PWM. And what's really cool about this, what I need y'all to look at, we just ran a couple of things to configure a peripheral. There's no like loop running here. Right now, the actual processor itself on the microcontroller is off. Literally off. And it's still running our PWM like we want. So it's all based on these peripherals. So what that means is in the next video, maybe I want to try and actually merge these things together. Maybe I'll make something like based on a value of 1 to 10 or something, or 1 through 9, or 0 through 9, control the brightness of my LED. But hopefully you can start to piece a little bit together to see, well, if I'm controlling a peripheral, and in my UART control, I'm really just messing with another peripheral, now I can start to think about how I want to achieve a goal. How do I get this microcontroller as a whole thing to do what I want?